Welcome to TechGig webinar, our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, TechGig has initiated a series of webinars conducted by industry experts to give a crisp insight of various domains. Today's session is first in the Android development series, and topic for today's webinar is Android architecture and application fundamentals. We are delighted to have Mr. Vivek Arora, manager at MySpark Technologies, as our guest speaker. Vivek has more than 10 years of work experience in software development and project management in association with various MNCs like Telefonica Spain, Canon Japan, Motorola, LG, and MySpark Canada. He is an expert project planner and implementer with strong product development and project management skills. Vivek has working experience on various Android-based mobile handsets and tablet product development. Gentlemen, this presentation will continue for next 45 minutes and we'll take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Vivek.
We are not able to hear you, Vivek.
Hello.
Now we can hear you.
Okay. Shall we start? Am I audible now? Shall we start the session?
Yeah, we can start now.
Okay. Good afternoon, everyone. Myself, Vivek Arora. Today we are going to talk about Android development. Before we dig into the technical details of Android development, I would like to thank TechGig for giving all of us such a wonderful opportunity to connect in this forum where we can discuss about all the technical stuff. So thanks TechGig once again, and welcome to all of you, and let's dig into the session now. So the agenda of the session today is to understand Android development, in which we are going to focus on Android architecture and application fundamentals. So okay, for the beginners, I get to hear a lot of queries. What actually is Android? Is it really a suite of applications? Is it a middleware, or is it an operating system? And there is a lot of interest in the market where people want to understand if they have to develop an Android application, what really is required. So if you go by the Google definition, it's Android is actually a complete software stack for mobile devices that includes operating system, middleware, as well as applications. So the key thing is Android is not a bit and piece of it. We have a lot of open source solutions available. Android has done something by creating an ecosystem and combining all these things in an open software stack. So when we look at the operating system uses a kernel which is based on Linux 2.6, and there are a lot of new features which are introduced by Android. Some of the interesting ones among those are like DVM, which essentially means Dalvik Virtual Machine. So Android does not use the standard JVM or KVM. It has done a lot of optimizations on top of that and come up with something called Dalvik Virtual Machine, which we are going to look in more detail in further slides. It has got an integrated browser. It has got a very lightweight SQLite database support. and this has got GSM telephony support, which is based on the hardware. So GSM telephony is one of the feature which has a lot of dependency on the hardware. So why do we have so much of talk about Android? Okay, this is what Android is, the whole set of software stack. But last couple of years or 3 years, there has been so much of talk about Android, and the way Android has led the smartphone market. What are the basic reasons behind it? The key reasons behind so much talk about Android are, first thing is flexibility and scalability. What necessarily we mean by flexibility and scalability is Google itself has given a set of applications with Android, but the whole developer community can develop their own applications, and they have access to same resources and public APIs which are accessible to the core APIs, core applications. So there is no differentiation between what access core application has got and what access another developer outside Google or in the market has got. So it gives a lot of flexibility and scalability for the existing system to grow very fast. It's quite robust because it's based on Linux, Linux 2.6 more precisely, and it gives a lot of freedom to the end user. End user essentially is the king. End user decides which application end user really wants to use. So when we say which application end user really wants to use, there is essentially no difference between your core application and downloaded applications. So end user decides which application he or she wants to keep on the device, which application he or she wants to use for any activity. Because of all these things, there has been a lot of developer community support, because this has given a platform to the developer community where they can kickstart their application development without much expenses, and the reach to the masses is quite reachable. One bigger problem which Android has tried to solve is fragmentation, which essentially means before Android came in, there were already a lot of phones available which could run various applications. There were a lot of companies already doing this, but each brand has a different application environment, which led to fragmentation. You develop an application for one brand, it will not work for another brand. What Google or Android has done is they have given a same environment which is open, all the APIs are open, which reduces the fragmentation. So if you develop an application for an Android device, it runs on all the Android devices, and this being free, this has been spreading very fast. Although Android has tried to solve this fragmentation problem, but one of the key challenge which Android faces among itself is also happens to be fragmentation. The reason being Android has been developing very fast in last few years. So the application which you develop on one version of Android may or may not run on another version of Android. And so some part of fragmentation still exists in Android, but as the time goes by and Android stabilizes, this fragmentation is reducing day by day. So these are the key reasons why Android is so much talked about now. So the next thing which we are going to look at, how did this come in so fast? Android was not heard maybe 5 years back. It was not popular 2 to 3 years back, but last 2 to 3 years Android has been rising just like anything. So was it really started by Google? Actually not. This was started by a startup based out of California, which the startup itself was called Android, which was later acquired by Google. And Google had a vision which was already a leader in search and LBS capabilities. LBS is location-based services. And Google wanted to take these capabilities to the exploding market of mobile devices. That was the reason Google thought to acquire Android Android and did uh, by really opening it up. Later in together and decided to take care of Android. If you would like to have a peek in to the kind of companies which are already part of Open Handset Alliance, which is supporting Android, so you can have a brief look at this, which tells you that major companies
Hello. Your voice is breaking a lot.
are already part of the
We can't hear anything. Your voice is breaking.
Hello, hello.
Yeah. It seems much better now. Please go ahead. We can't hear you. Your voice is not coming at all now. Can you please check the micro settings?
Hello, am I audible now?
Yeah, you are audible now. Please continue. Thanks.
Okay, great. Yeah. Sorry for this delay. I think there was some connectivity issue. So, okay, this is what Android has done to smartphone market in last couple of years. If you look at 2010, Android has a contribution of only 26%, but if we look at the last year, this has grown to 43%. So this is in brief gives us a snapshot that what Android has done to smartphone market, why Android has been picking up so fast. Okay, now we understand what Android is, what has Android done in last couple of years. Now we are going to understand uh, the the architecture of the Android. Okay, yeah, this is the architecture of Android. If you look at it, it is a stack of layers, which shows at the bottom of it as Linux kernel. As we have already seen that Linux kernel is based on 2.6. On top of it, we have got libraries shown in green color, which are actually native libraries developed in C and C++. These are the libraries which expose the capabilities through application framework, which are in turn used by the applications. So the key thing which application framework is doing here is to enable reuse of various components. So libraries expose these capabilities for application framework, which enables reuse of those components. One of the critical component added by Android is Android Runtime. We also spoke very brief about Dalvik Virtual Machine earlier. Dalvik Virtual Machine is part of Android Runtime, which has been optimized by Android for mobile devices. And along with Dalvik Virtual Machine, Android Runtime contains core libraries, which essentially provide a substantial subset of Java 5 Standard Edition, which includes your collections, IO, etc., everything. So at the bottom we have got Linux kernel, we have got native libraries and Android runtime. On top of it we have got application framework, and on top of it we have got the applications. Some of the key applications are already provided by Android, like contacts, browser, and there are a lot more which are all getting developed and developed daily. So this briefs about the basic architecture of Android. Now we will dig deeper and understand all of these layers in more detail. So if you look at the Linux kernel, which is at the bottom of the stack, it essentially uses Linux 2.6 kernel, and it utilizes the core services, for example, security, memory management, process management, network stack, and driver model from this kernel straight away. And this kernel has got some enhancements which are done as part of Android, like low memory killer, which essentially means when we are developing applications, we don't need to bother much about memory. Android manages the memory of the whole system based on some priority which is taken care, and it also has enhanced the power management. The next thing which we looked on top of Linux kernel is native libraries, which are C and C++ libraries exposing various capabilities through Android application framework. As part of native libraries, we have libc, which is a standard C library tuned for embedded devices. It has got SGL and OpenGL, which are there for 2D and 3D. There is a typo mistake. is 2D and 3D graphics support. SGL is nothing but the people who are from graphics background. It's scalable graphics library, or it's also called Skia graphics library. So this gives the underlying 2D graphics engine, and if we are really interested in the code part of it, we can find most of these APIs in android.graphics.driable. And OpenGL is to support the 3D graphics, which is based on OpenGL 1.0. So these libraries either use hardware 3D accelerators if they are available, or they use the highly optimized software rasterizers. Then we have FreeType, which is used for bitmap and vector font rendering. SQLite, which is a very lightweight relational database engine. Then an important component manages access to display subsystem. So the key thing of Surface Manager is to seamlessly composite 2D and 3D graphics. So we have got libwebcore, which is a modern web browser engine. With web browser, it actually gives us an embeddable web view, which can be used in apps. We have got media libraries, which are based on packet videos open core. So these libraries support playback as well as recording of many popular audio and video formats like MPEG-4, H.264, MP3, etc. Then we have SSL, which is Secure Sockets Layer Cryptographic Protocol for secure internet communications. So these native libraries, as part of application developer, we may not interact directly, but having a knowledge of them helps us to understand better our applications. This is the Android runtime, which contains Dalvik virtual machine, which actually runs optimized file format .dex. So this does not work on Java bytecode, although all the application development at the top layer is done in Java, but it does not work on Java bytecode. It does one more level of optimizations and generate Dalvik bytecode. So the normal, when we are working with Java applications, we have got java.class and .jar files, which are compiled to .class using Java compiler. So one additional thing which happens in Android is gives us another output .dex, which is Dalvik executable format. So this supports multiple virtual machine processes per device. To achieve this, if we have to have multiple virtual machine processes per device, memory is one of the big constraints. So Dalvik executable or DEX format is optimized for Android. If you have 10 different applications, you got to have 10 different processes in general, and every application runs in its own process. And every process has got its own, relies on the same Linux kernel for underlying functionality. For example, you need threads, you need low-level memory management. For all that, it is still going to depend on Linux kernel. Then we have core APIs. We already had a brief discussion based on Java 5 standard edition. So these are written in Java. So now till now we see we had native libraries, even DBM was native, but in case of core APIs, these are written in Java as we have in application framework or in case of applications. So this gives us various data structures, file access, network access, or graphic support. Okay, so now we reach to application framework, that component which most of the applications interact directly. And this application framework contains
Sorry for interrupting you once
three major
again.
components.
Your voice is again
Yes.
very low, and people are unable to hear
Very
you.
low, is it?
Now all of the sudden it has become good.
Can you hear me now?
Yeah, it's better now.
Can you hear me now?
Yeah, it's much
Okay,
better.
great.
Thanks.
Okay. So in application framework, we have many components. One of the very important component of application framework is activity manager. This is the component which actually manages life cycle of the applications and gives us a common backstack for navigation. So we are going to look more deeper into this in further slides. We have got package manager, which essentially holds information about various applications loaded in the system. At times, applications may need information about other applications, and package manager is going to help us in that. We have got something like resource manager, which gives us access to non-code resources such as localized strings or various other, we can have layouts, so many resources we can have in the form of PNG, BMP as well as XML. So resource manager helps us to get access to those non-code resources. We have got content provider, which is extremely important component of application framework. This gives us access to the data from other applications, for example contacts, or to share their own data. As we discussed briefly earlier, that every application is running in its own process. So one application does not have access to the process area of another application. But if they want to exchange data among each other, they can achieve it through content providers. We have got notification manager, which helps us to display custom alerts on status bar. This notification manager is primarily important in case of broadcast receivers. We are going to look at what is a broadcast receiver. So it helps us to display various kinds of alerts on status manager. We have something like location managers, which handles information about the location. And we have telephony manager, which handles information about telephony, which is again, yes, if it is using GSM telephony or some other kind of telephony, there is some dependency on the hardware. So these are the core services which are provided by application framework. Apart from this, there are some more services which need hardware support. For example, you want Bluetooth service, you want Wi-Fi service, USB service, or any sensor. So all these things become hardware dependent. Okay, so now we have reached to application layers. As we already saw, Android ships with a set of core applications, for example, contacts, calendar, or maybe email, SMS, browser. We already had a look. And most of the application developers code sits here with other core applications. And the key thing, even Google applications use the same public API that is available for open developer community. And all applications in this layer are written using Java. So we have seen we can have Java source code, and we can have resources which can be in XML, PNG, etc. I'm not sure how clear this slide is to you. I will try to speak it uh, as clear as possible so that you understand how do we reach to an application. An application in Android is nothing but an .apk file. So finally when we compile and build our source code, we get an .apk file which contains the whole application package. So how that APK gets generated? When we start application development, we have got Java source file and we have got our resources, which are non-code resources. The Java source file passes through a Java compiler and gives us an output as .class files, standard Java application development process. Then these .class files are given as an input to DX tool, which gives us .dex files. Then we have got a tool called AAPT, which is nothing but application asset packaging tool, which takes .dex file as well as these XML and PNG and packs it into an APK. And finally, this is an APK file which gets installed on mobile devices. So this briefs how we convert our source code or resources into a final APK file which gets installed on a mobile device. We have talked about like all applications in Android are treated equal, whether these are core applications or non-core applications. Then if they are treated equal, it seems obvious that security is a concern. That if every application has a similar privilege, then every application can damage the other application. So once an application is installed on a device, each application actually lives in its own security sandbox. So that's a way to achieve security for Android. So Android is actually based on multi-user Linux system in which each application is a different user. And by default, the system assigns each application a unique Linux user ID. Each application is having its own user ID, own process, and each process has got its own virtual machine or DVM. So essentially by default, every application runs in its own Linux process. So Android just starts the process when any of the application component needs to be executed. In the coming slides, we are going to look at various components of an application. But the idea here to understand is, as soon as Android starts the process, whenever any of the components needs to be executed, and when that component is no longer needed, it just shuts it down. So that's how Android manages its security. Okay, we have looked at application layer. We have looked at how security is achieved in an application. Now we are going to look at what are the various application components which help us to come up with an application. So these are the 4 components in an application. The foremost important one is an activity, which is nothing but a screen on a UI which you can see in the mobile device. You can actually instantiate an activity from any other activity or screen. And if you want to do it, if you really look at the UI of any mobile device, you get one screen, or you have a home application or home screen. You press some soft key or hard key, it gives you another screen. So that screen is nothing but an activity in case of Android. And when you want to switch from one screen to another screen or one activity to another activity, Android uses a mechanism of messaging which is called intent and intent filters. Intent and intent filters, which help us to move from one screen to other screen. We are going to look at these intents and intent filters in the upcoming slides. So idea here to only use intent and intent filters. Then we have something called services, which are long-lived and they run without UI. So it's possible for you to connect to, or in Android terms, bind to an ongoing service and just start the service if it is not already running. So if you have got a background service, you can bind to it, or if you want to start it afresh, you can start it. And once you are connected to a service, you can seamlessly communicate with the service through the interfaces, whatever the service exposes. There is something called content providers, which is used to store or update or retrieve data. So this data is generally stored in file system or SQLite database, and it's extremely useful for sharing big chunks of data across applications. Content provider actually, when we are looking out from an application point of view, we do not applications do not talk to content provider directly. They actually talk to content resolver, an entity called content resolver, and content resolver can talk to any content provider. So whenever there is a content provider, it implements a standard set of methods that enable various applications to retrieve or store the data. But how applications really do it? They invoke content resolver APIs, and then content resolver talks to content provider to achieve the required functionality. Earlier in the session, we were talking about broadcast receivers. This is the last component of an application, but equally important whenever you want to react to an external event. To take an example, let's say you get an incoming call on your mobile phone and you want to do something extra than the default application whenever a call comes. So you got to register the broadcast receiver. So whenever the phone ring comes, or have any UI. But you can use the application framework. You can use the notification manager to alert the user. So your update may come in the status bar at top of the mobile phone, showing the current status update. Okay, so we have seen what are the of now we are do we activate the thing about start activity, start service, or broadcast intent, which helps us to activate various components. So start activity, as the name itself signifies, is to launch an activity. Start service, or we can also have bind service. Whenever you want to communicate with a background service, and broadcast and receiver component. So, and in case of content provider, the fourth component, we already saw that we need to call content resolver API to connect to content provider. So there is no activation as such required for a content provider. So when we pass these intents to these functions like start activity or start service, what kind of information is carried in it? It carries an action which tells what general action needs to be performed. For example, if you are trying to make a call, you may give an action call, or if you want to edit a document, you may say action edit. So what general action needs to be performed? The second thing is on what data this action has to be performed. So action and data are actually paired. So the different kind of actions are paired with different kind of data. For example, if your action is action edit, your data field should contain a document which has to be displayed for editing. Another information carried in intent is category, which contains additional information about the kind of component that should handle the event. So this category tells which kind of component can handle the event. For example, you have a hyperlink. Your category may be category browsable, which can tell you what kind of component can handle it. Then it carries something called the component, which is the class name, in case you want to pass an intent to a specific component. For example, you are in activity A and you want to start activity B. So you already know the component name of activity B. You can just specify the component name there and activity B will be invoked directly. So if you specify the component name, Android system does not need to check intent filter like which activity has to be launched. It can directly invoke the component which is explicitly specified. If we don't specify this component explicitly, Android system is going to decide based on action, data and category which component should be launched. Then we can also bundle some extra information in the form of key value pair along with an intent. We just talked briefly in the last slide about the component name. What happens if we specify the component name or if we don't specify the component name? So there are essentially two kinds of intents, explicit intent and an implicit intent. Explicit intent in which we designate the target component. We specify the component name, and in that case nothing specific is required. Android system just launches that component. But in case of implicit intents, we do not name the target, and Android system must find the best component or a number of components. In case Android system finds more than one component, then Android system may give this option to the end user by listing all the components and let the user choose and decide which component he or she would like to launch. So how Android system resolves that? Android system compares the content of intent object against intent filters. So whenever my application wants to listen to a specific intent, I need to define an intent filter in a file which is called Android Manifest.xml. We are going to look at that file also in coming slides. And this file helps Android system to compare the intent object and decide which all components can handle this intent. But when this comparison is being done, only three aspects are consulted: action, data and category. So it does not take care of component name anyway, because if component name is there, it becomes an explicit intent, and it does not take care of even extras or other field when this comparison is being done. So what are intent filters? Intent filters are a mechanism to inform the Android system which implicit intents they would like to handle. So if my application wants to listen for phone ring, maybe I have to, or let's say my application would like to know when the phone is booted completely, I have to uh, mention it in my intent filter. So activities, services, and broadcast receivers can have more than intent filters, obviously, as they may be interested to listen more than one intents. And these intent filters are set up in applications manifest file, which is called as Android manifest.xml as intent filter elements. So an intent filter has fields that parallel the action, data, and category fields of an intent object. So whenever an intent object is created, this data is fed in, and the same data is mentioned in intent filter. If Android system compares and finds them to be same, it makes out that this component can handle this intent. And there are some, we have talked about action, data, and category. There are some special action and category, like special action is main and the special category is launcher. Whenever you have an activity in your application which needs to be launcher for your application. For example, you have an application with 4 activities A, B, C, and D, and you want whenever your application gets launched, activity B should be launched first. Then activity B may flow to other activities. So you got to have an intent filter which specifies for this activity action as main and category as launcher. Based on this, Android system knows this is the first activity which has to be launched. This is the manifest file we talked about. It is must for each application, and the name must be kept same, and the name should be Android manifest.xml. The purpose of this manifest file is to present essential information to the Android system, like this names the Java package for the application. It describes various components of the application. It declares the permissions application must have to interact with other applications. So this is another new concept of permissions. If my application wants to have an access to context database, I must ask for this permission in Android manifest.xml. Advantage of this permission is when my application gets installed, Android system is going to show the list of these permissions to the end user during installation, which makes the end user aware all these permissions are required by this application, and end user may choose to install or not to install this application if he sees any risk in installing the application. In case end user sees application is asking for a permission which is not really required, end user may choose not to install that application. Then in this file you need to declare the permissions that others are required to have in case they want to use your application. This is a brief about application resources, which can be like images, audio files, etc. The layouts of the activity. You can have various kinds of layout of an activity like linear layouts, relative layouts. So your default UI is saved in, let's say if you are talking about layout, and if you look at an application source code, resources are present in a folder res, and the layouts of the that application are present in res/layout directory. So all these XMLs will lie in this directory. So advantage of keeping these resources separately is you can update application characteristics without modifying the code. And you can have alternative resources for a variety of different configurations. For example, you want different resources when your device is in landscape mode, and you want different resources when your device is in portrait mode. So you can keep different set of resources in respective folders, and Android system is going to decide, is going to pick up the resources accordingly. Okay, we understood about various application components. Here I have picked up home application launch. The idea of picking up home application is because this will tell us what all is happening under the hood. So bootloader first thing loads the Linux kernel and starts the process. So the first thing which comes into picture is init process. So init process starts our Linux daemons, all the daemons like USB daemon for your USB connections, or in case you have telephony support, the real daemon is going to come in picture. And an important daemon is, very important daemon is Android debug bridge. Then it starts a zygote process, which is a nascent process which actually initiates each DVM instance. It starts a runtime process, which actually initializes and registers something called service manager, which becomes our default context manager for handling various services. For various services, what we have talked in our application framework, like activity manager, package manager, etc. So as we saw, the runtime process is started. Then runtime process sends a request for zygote to start the send process. And since this is also a separate process, so zygote forks a new VM instance for the system server process and starts service. The system service starts the application framework services, for example, activity
So,
manager.
once again, the
So after
voice is
system
very low.
server loads, hello,
Once again, the
hello,
voice is very low now.
is it is it audible now?
Yeah, yeah, it's better now.
Okay,
Yeah.
I'll be a little louder.
Okay, fine.
So after system server loads all the services, Zygo creates home application in a separate process, and subsequent applications are launched in their own process. So we will now understand this in the next diagram, which tells how this is really happening. So we have our init process, which starts the daemon processes, the runtime process, and zygote process. Zygote process starts the system server with separate Dalvik VM, and in turn all the services, activity manager, package manager, etc. And then it launches the home application. So home application becomes our first application. Any application launched after that is coming on top of that. So this home application launch helps us to understand the whole flow, what is happening inside when any application or process is getting launched. So this is a brief about Android development, what are various applications. So I would like to open this forum now for the questions. If you have any questions, please feel free to ask me. Okay. I have a, the question is why DVM is introduced in Android. Uh, the question is asked by Akshay. As we briefly discussed uh, during the presentation, uh, DVM is introduced in Android to optimize the current virtual machines. As part of security sandbox of Android, every application is running in its own process, and that has got its own DVM. So one of the basic requirements for DVM is to have minimum memory footprint. So that is the reason that the optimizations which are done in DVM, and it is introduced in Android. Okay, I have one more question here. Does it mean an Android application developer must have the knowledge of Java? This question is asked by Rajshekhar. Yes, majority of Android application development happens in Java. So understanding Java for Android development. Okay. We have one more question where it says Android development is related to mobile development application, but don't you think this is in boom now, but won't be there in a long-term basis? The question is asked by Rathod. Honestly, I don't think so, because uh, this is not only related to mobile development application. If you see now Android, it is coming everywhere. It is already there in mobiles, it is already there in tablets, it is already there in TVs. And recently Samsung has launched a washing machine which runs on Android. So this Android is more about an ecosystem which is existing without much cost, and the development is too easy. Being supported by Google and Open Handset Alliance, this definitely makes it a very, very optimistic bet that this is going to go too long. We have one more question. Can an application be made back version compatible? The question is asked by Lokesh Patija. Yes, we can make an application backward compatible. When we develop an application, we actually specify which API version we are going to use. But if you happen to use the APIs which were not available in previous version, then your application will not be backward compatible. So you really have to see which APIs you are using, till which version you want to be backward compatible, and the same way you can follow it on. The next question is Java code has been converted into class files. And is the same converted to DEX? If so, then what is the use of such a new conversion? This question is asked by Ajit. So the answer is yes, it is the .class file which is converted into .dex. As we already discussed that the .dex has done much more optimizations than what was there in .class files. The way pools are maintained in .dex file are different than the way they are maintained in DOS class. So this is an optimization on top of .class which helps. We have one more question. Which version of SDK should we use with Eclipse? So I think that depends which version of SDK you want to use with Eclipse, depending on what you are targeting at. So you can recently, if you are talking about mobile devices, Gingerbread still seems to be the one which is going. But if you want to develop only for tablets, Honeycomb may be your choice. And we also have now ice cream sandwich in place. So it depends what kind of devices you are targeting to and which SDK you would like to choose accordingly. Okay. We have a question. Does Android and Symbian use same system architecture? The question is from Santosh. Uh, Honestly, I'm not very sure because I've never got a chance of working on Symbian. The only thing I can say is like we had a brief about Android system architecture. So maybe the somebody who, I'm not sure if you have some idea about Symbian architecture, then someone who has worked on both would be a better person to answer this query. We have another question which says the first thing I feel happy about uh, Android is the open source. Open source always has security issues. How does Android overcome it? Yes, open source has a variety of security issues. Now the key thing is that Android being backed up by Google and Open Handset Alliance, there is a lot of work going on from security aspects. But yes, we can never have maybe a foolproof solution without any hitches. We have a question. I recently learned about routing the Android phone. Does it risk the security of application and data? And what actually it does in system? This question is asked by Atul Yadav. See, the routing the Android phone essentially gives you the root access to the device. So as we know that Android is Linux based, so you essentially happen to have root access on the device, but does it risk the security of application and data? Not directly, but most of vendors consider it to be violation of warranty in case you happen to root the device. We have another question. Uh, is it possible to run same Android application on WinCE? Okay, the question is asked by Vipul Patel. If you ask if you want to run it directly, maybe not. You cannot run an Android application directly on WinCE. but there is a lot of development happening on cross-platform, which helps you port your applications quite quickly. So there is a lot of information available on internet where you can develop an application for one platform, and then the same application can be ported quite easily for other platforms. We have a question: can a service, not activity, be started through broadcast receiver? The question is asked by Lokesh Bhatija. Um, yes, definitely you can start a service. In fact, if you want, you can also start an activity from a broadcast receiver. But starting an activity from a broadcast receiver must be avoided, because user might still be doing something on the device, and broadcast receivers receives an intent. If you happen to start an activity, you may actually disturb the user. But if you want to start a background service without a UI, then you can definitely do it. So okay, we have another question. Can a service, not activity, be started through broadcast receiver? Yes, I answered yes. If yes, how can I bypass the existing broadcast receiver of the phone if I'm building a call blocking application? See, call blocking application is something which many people have been trying to do. The idea is call is such an application which generally no one would like to block, but in some cases, yes, some application development is going on where people try to block a call. So in my opinion, it would not be so straightforward that um, since you cannot block the other broadcast receiver, you might have to look at being first at receiving the intent and doing the trade. But I'm not sure whether that would be advisable or not. Okay, we have one more question. I'm developing an application for Gingerbread version of Android. Will it be compatible in ice cream sandwich or forthcoming Android versions? And why does Google name Android versions as snacks names? Okay, if you're working on Gingerbread, The idea is how well you are able to take care of the device finally it is going to run on. More or less it should run, but if you have not taken care of the UI properly, it may not give you the required effect as you may would like to have. If you have any more questions, please feel free to ask me. Okay, we have a question. What is the difference between content provider and SQLite database? Asked by Akshay Tadia. See, content provider is a mechanism using which you are going to access the database. So whenever an application wants to store or retrieve some data, it is going to talk to content provider. In fact, as we discussed, it is going to talk to content resolver, which is going to talk to content provider, and then that content provider might be accessing SQLite database internally. Okay, we have another question. Why Android OS is virtual machine? The question is asked by Rajita Anish. See, when the key thing here is the Java has an advantage of being platform independent, and here the straightaway choice could have been JVM. The only difference which Android has brought in to optimize that to convert into a DVM. So that's the only difference which Android has brought in here. We have a question. Is any platform can be used to develop application for different types of platform like Android and Xcode? The question is asked by Yogendra Singh and Yogendra Singh Yaduvanshi. See, there are various platforms which let you develop application for multiple platforms like Android, Windows, etc. But I'm not sure about explicitly Xcode which of the platform would be able to help you. But there are definitely platforms which help you develop applications for different kinds of platforms. We have another question. Is there any guideline to make faster and lighter applications? The question is asked by Anand Mishra. See, when you are designing any application, the key thing, first things which we have to keep in mind with respect to Android is the UI issues, which essentially mean if your application has to run on different kinds of devices, different sizes of display, what all things you can take care so that your applications work properly. But if you want to really develop faster applications, you might choose uh, to write native code instead of everything being in Java. You have something called NDK, which lets your applications talk to native code with JNI. Although this has been debatable whether these applications are really faster than the applications written purely in Java. So there is some kind of experimentation needed apart from just coding guidelines which you may follow to make your applications faster. Okay, we have another question. Uh, what type of applications monetize well in Android market? The question is asked by Nikhil Bansode. See, if you see right now in the Android market, there are already millions of applications existing, and Android is doing best to segregate them as cleanly as possible. But being so many applications in the market, you really need to look at what different you are trying to do and what is the way you can bring it to the awareness of the masses. Social networking ways, keeping your applications catchy and crisp, which help to get the first attention, and most important, if the product is good, it's gonna sell. So you got to see how big the problem is which you're trying to solve, or how good the proposal is which you're trying to bring in. So there would not be any definite answer like what type of application monetize really well. Do we have any more questions? Okay, thank you everyone for your presence. If you have any more questions, maybe you can get in touch with the provided email ID, and I would be happy to give you the answers what I can. Thanks Tegik once again for arranging such a wonderful audience. Thank you very much.